Hey, good evening, everyone. Guys, I'm audible. Hope I'm audible. Right. I'm Akhil, and I'm really excited to welcome all of you to the SQL crash course, Database Management Simplified. In this today's world, you see, essential SQL is an essential skill for managing, analyzing, and you know, extracting valuable insights from the databases. Right. Over the next 10 days, we will take you on a structured journey covering everything from basic queries to the advanced data operations, helping you build a strong foundation in structured query language. So, our goal is to make this training interactive, practical, and insightful. So, I encourage you all to engage, ask questions, and make the most of this learning experience. So, before getting started, I just want to show a playlist. So friends, this is our YouTube channel. Okay, so I see majority of the people joining today, new people coming in, right? So if you're joining the sessions for the first time, so we have, this is our YouTube channel, and you know subscribe to our channel, and you know if possible, and if you find people who are actually looking out for the courses, okay, it might be structured query language SQL, the ongoing program, or we have recently done a program on Power BI. Okay, so where we get the complete playlist of Power BI sessions. So this particular playlist, we have it on Power BI. Okay, so it was done for 20 days. So even if you're not aware of Power BI, a BI tool, business intelligence tool, okay, so just go and go through the lectures of Power BI. And we have also done a sessions on Python to AI. So we have completed the sessions from Python to AI, starting from the scratch, the basic topics in Python, then to the intermediate level of algorithms under machine learning. So all of them are available under the short-term trainings English. Okay, so folks who are joining for the first time, okay, I sincerely request all of you to go through these sessions if they are actually helping you. Right, so with no delay, let's get started with today's topic. Okay, so it is introduction to SQL and DBMS, database management system, where we will understand how databases work, then why SQL is so important, and how it plays a key role in data management and analytics. Right. So the agenda is here, friends. This particular program, we are going to do it for the coming 10 days. So what are we going to understand is, we'll initially understand what is SQL, what is DBMS. Okay, so digging the history of database management system. Okay, how the data is stored in the real world. Then what is the language that is generally used to communicate with these databases. Everything we are going to understand in today's lecture, followed by the SQL commands. Okay, so what kind of commands can you have under SQL? Okay, then the data types and operators. Okay, in order to work on the data, in order to store the data should represent some of the type. Okay, so under the data types, we are going to learn the different data types that are used in SQL, then operators. Okay, so what exactly are the different operators that we have under SQL? We are going to learn on this topic, followed by clauses. So the important topics, clauses and constraints. Okay, so what exactly are the clauses and what are the different constraints that we have, okay, while storing and retrieving the data, followed by joins. This is also important. joins and union. Yep, an important topic that one has to learn. And you know then indexes, subqueries and views, and finally the window functions. If time permits, we'll also see you know how to integrate Python with SQL, I mean with the database. Okay, so how are we going to integrate Python and database? So whatever you're seeing here under the agenda slide, we have designed this program especially for the people who are going to represent the interviews. In the point of interviews, SQL is considered as a primary skill, whatever the role might be. Even if you might have enrolled for data analyst or data scientist or data engineer, even SQL, database management administrators. So whatever the role that is related to data, okay, so they should have the primary skill, that is SQL. Okay, so what, keeping all those points into the in the mind, we have designed this particular program. And in the coming 10 days it will be like hands-on sessions. Okay, probably today it might not be a hands-on session because it is just an introduction part. But tomorrow, yes, we'll start using one of the database management system. Okay, so for that, probably we will come with one recorded video, how the installation, how the software has to be installed. And following these steps, you are supposed to install the software in the machine, your local machine, and you can start practicing. Okay, right. So friends, before I actually start the class, I would like to add few more points. One is with respect to the questions. So I'll take up all your questions, even it is technical or non-technical, whatever it might be. I'll take up your questions at the last. Okay, at the end of the session I'll take up your questions. Then um, on daily basis the sessions will be from 6 to 7. Okay, sometime we may extend as well. Okay, depending on the scenario we'll extend. Then uh, you know I think I'm done. Yep, so let's get started, friends. So let us get introduced to what is, you know first, in order to understand what is SQL, one have to understand what is a database. What exactly is database? We'll understand first. When you talk about database, you know I have to go back to 1960s, isn't it? Yes. The reason is, in early days, probably around 1915 or 1960s, how the data used to be stored is using flat files. The offline files that we have, Excel file, CSV file, okay, XML, JSON files, whatever it might be, data used to be stored in the flat files. But in those days, is the data generated more on daily basis? Not exactly. Passing year by year, you know what we have observed is the amount of data that we are going to store has been increased a lot. So is it possible to store all such kind of data in the flat files? Not exactly. And moreover, if you are storing the data in flat files, there is no kind of structure. Okay, you cannot have any kind of structure established. Relationships, not even relationships can be established. So these are the major issues that our earlier scientists have observed, and that has you know triggered to evaluation of databases. Okay, so the first database that was launched are hierarchical databases, and this is the first database model. Okay, in late 1960s these databases came into the picture, and these are from IBM. Okay, so you'll find it as a tree like structure. having parent and child relationships, one down to the other. So the parent will be representing the main. So even if you observe a tree, okay, you'll have roots, then followed by the branches, then followed by some kind of leaves, fruits, and so on. So this is representing a tree, right? In the same way, the parent child. So this particular node is representing child, and this will represent parent. In the same way, if you go in this way for this respect to hierarchy, this will represent child, this will represent parent. In such way, we'll have the relationship between the nodes. So these are the first database model that was introduced, the hierarchical databases. Okay, but there is a limitation for these hierarchical databases as well. Okay, the main reason is the structure. They found the structure very rigid, and even though if they want to come up with any new requirements, they are unable to adapt to this tree-like structure. Then our scientists, our folks have come up with network databases. Because when you observe network databases, you'll something feel like you know where it allows us to have many to many relationships, not a single relation. You can have end to end relationships. Okay, so these are actually built to overcome the relation, the limitations of hierarchical databases. Even the structure is very fine, and it is easily to helping us to adapt for the requirement. And finally, this guy, EF Card, had made our databases very simple by introducing the concept of relational databases. So the ongoing databases, whatever we are using, they are relational databases where this person has included the concept of relations. What exactly are relations? Relations are representing tables. What is a table? Friends, what is a table? Come on, I want the session to be interactive. So I should see some kind of responses in the chat. Keep on interacting for the questions that I ask, so that uh, yep, good. So a table is a combination of rows and columns. So what are rows? What are rows? This is a table, fine. Nothing but it is technically named as relation. Good, 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 good going. The vertical one, whatever you see here, are named as columns. These are named as columns. So friends, I'm not that much good at writing, so do adjust with whatever I keep on writing. And the horizontal one are called as rows. So finally, we were able to store our data in the form of relation in a table. And you can have multiple relations between the tables. What exactly is relational database? We are going to understand. In a couple of minutes, we'll understand what exactly is RDBMS. Okay, we'll understand DBMS, then we'll go with RDBMS. Fine. This is clear. Yep. Then, did we stop? No. As you see how the technology is increasing, even there is a lot of research that happened on databases. Okay, so best because of this, you know, research, next to relational databases, during 1980s to 1990s, we have object-oriented databases. Means the data used to be stored in the form of objects. So something, oops comes into the picture. So generally, when we talk about oops, majority of the people, they think about programming, right? Yes. So using oops, we were able to store the data in the form of objects. Yes. Then next to object oriented databases, we also had, you know NoSQL and big data era. What exactly is? So we are in this era, friends. Right now we are in this phase as the data is generating very big. Okay, so we are not, we cannot just go with the traditional databases with whatever we had. Okay, we are supposed to invent, or we are supposed to come up with new databases, and we finally had them in this era. What is big data? The question comes, when you say data, you know the data is representing the values with respect to the organization, whatever the business that we run. you know on daily basis, we'll store the values, and it represents the data. In the same way, what exactly is big data? Big data means, Akil, the data which is very big is big data. Am I right? What is big data, or how do you define big data? I see some of you folks who have also joined the previous programs, because in you know from Python to AI, in that particular program, we have discussed what is big data. So I'm expecting answers from you. A few of you have also attended the previous sessions, right? Yep. So what is big data? Make it very simple. Come on, friends. Big data is the data, you know, which is very big. How big it is? Huge volume of unstructured. Okay, is it only unstructured data, my friend? It can also be structured data, right? Yes. Then cannot be easily managed. Okay. Then, so the data which cannot be easily managed is nothing but big data, is what my friend says. It is field of data, or not exactly. Huge amount of data. That's what. How, you're referring it to huge, right? Huge amount. How big it is? Is it this much big, or this much? How, which much? How much? Mix of structured and unstructured data. Okay, so only if you mix structured and unstructured will it be big data. hmm. Terabytes. Okay. Hmm. So what about petabytes? More than it. Right, so let me define what is big data. So, generally this should be your answer, friends. From here onwards, you know, your answer when someone asks you what is big data, you just talk about four V's. Good, good. Good answers, good responses I have got so far. But your answer should be very simple. Big data is the data which represents four V's. What are the four V's? Good. The first one is, you know, volume. Then what are the rest of the three V's? Velocity. Okay. Then variety. Hmm. Veracity. Okay. See, I'll explain all the four V's. The first one is volume, which is representing the size. When you observe in the real world, Okay, in the industry, you take banking domain, banking sector. At this moment, it's sharp 6:21. Okay, at this moment in India, how many transactions can you expect to happen in 1 minute? Can you tell, Akhil, it will be only one? I will laugh. Not only me, you know, you you cannot expect the number, because even it will be weird. Okay, there will be n number of transactions going at a single point of time. Okay, so what are these transactions related to? They are related to, some kind of the banking sector. So what's happening, the data is getting generated. Each and every transaction that we do is a is nothing but the data. It's a row that we have in the table, right? So the volume is representing size. At what size is the data getting generated on daily basis? Okay, then next to volume we have velocity, which represents speed. At what speed is the data getting generated? Is it very huge, or depending on the time it is generating? Yes, because at night time, can you expect the same number of transactions to happen? Probably no. Because that is the time where generally humans sleep, right? So you cannot expect the same kind of number, or that same number of transactions to happen in the same night time. Probably yes. Then variety in the sense, you know is the data that is generating structured or semi structured or unstructured? In the sense, is your data that is getting generated in the form of tables, or is it going to generate in the form of images, text, videos, audio, speech, whatever it might be, friends? All of these are representing variety of data, right? So yeah, it can be in any form. Any form of the data can be generated. Yes. Okay, so depending on the use case, you'll have the different types of data forms, right? The volume, the speed, and the veracity is finally representing the uncertainty in the data. Okay, you cannot find any kind of certainty. So these four V's together define data is big data or not. Okay, so this should be our answer from here onwards. Using four V's, we define data is big data or it's not big data. And for big data, for handling big data, we have different tools in the market. They are Hadoop, Spark, right? Probably you guys may have heard Spark, right? So this is the ongoing technology that is in demand. PySpark, Spark integrated with Python. Okay, so probably we'll also come up with the new sessions on Spark, probably in the coming few more months. Okay, so you see here, we also have NoSQL. Okay, these sessions are on SQL, right? Yes, we are going to understand the concepts of structured query language. Then what exactly is NoSQL? Give me 20 more minutes. We'll also discuss what is this NoSQL. Okay, so in this current market, we also have databases where they run with NoSQL. So what is this SQL and what exactly is NoSQL? We'll compare. We'll understand the differences. Okay. Anyhow, I have provided you a kind of answer here. NoSQL databases handle unstructured and semi-structured data. Yep, NoSQL stands for not only SQL. Okay, and these handle unstructured and semi-structured data. Then what does SQL handle? SQL handles structured. Okay, so what is this unstructured, semi-structured, and structured again? Come on, friends. I want you guys to answer. What is structured, unstructured, and semi-structured data? In the chat, please respond. Don't sit idle. What do you mean by structured, unstructured, and semi-structured? Structured data is the data which we store in the form of tables. Good. Only in tables? Yes. Only in the form of tables. Okay. Then, what about semi-structured then? No, no, no. I hope you are, you got my question. My question is, what is structured data? What is semi-structured data? What is unstructured data? I'm not talking about the query language. I'm talking about the different types of data that is present in the real world. Unstructured data is stored in the form of key value pairs. Okay. Yes. So I'll make it very clear. Friends, majority of you have attended the previous sessions, right? So what's happening? See, if you are able to store your data, see, I have a data, okay? Semi-structured is the data which is a mixture of structured and unstructured, isn't it? Not exactly. Anyhow, let me clear the differences. What exactly is structured, unstructured, and semi-structured? Structured data is the data which we store in the form of table, right? Table, rows, columns. But okay, fine. What else can be added to the definition is you also upfront define schema. We also upfront define schema. What is schema? Schema is representing data definition or data type. It means in the first column, I want to store employee ID. Okay, employee ID is a number or is it an text related data? Actually, it's a number. So if it is a number, you are supposed to fix the type. For this column, you have to fix the type. It's called as schema. Upfront, the schema has to be fixed for each and every data type. I mean, for each and every column. Then coming to semi-structured, we also store the data in tables. It is semi-structured. Okay, it is not completely structured. It is semi-structured. Then, what is semi-structured? The data that we stored in the form of tables in which we don't have schema to it. There is no schema. What is schema? Schema is representing your data type, your data definition. If you have name of the employees, obviously it is representing some kind of text. So you are supposed to choose a data type which indicates text. Okay, and instead of passing any text into that column, if I pass any number, it does not allow such kind of records. But here it allows because I'm not fixing the schema over here. So that makes the difference between structured, semi-structured. And finally, I have unstructured. Unstructured is the data which represents they're not in organized fashion. So the definition will be like this, friends. If you are unable to store the data, if you are unable to store the raw data in the form of tables, then it is called unstructured. And the examples are, you know, image. If you take an image, can you store an image in table? Yes, Akhil, I can store. How can you store it? Yeah, I'll do one thing. I'll convert this image into pixels, Akhil. So using these pixels, I'll store this image in the form of table. So whatever you told is right, but these pixels, are they representing the original image? Yep, they are representing, but using pixels, can I see the image? No. So that's what my definition says. The image as it is without converting to any other format, you are converting to pixels. If you are converting, you are able to store, right? If you take the original image, can you store the original image as it is in a table? No. So such kind of data is called unstructured data. What are the best examples? Images, videos, okay, audio, speech, text. All of these represents unstructured data only, friends. Okay, so this is how I differentiate structured, unstructured, and semi-structured. Okay, and even probably you guys must have heard about this. On this globe, on the earth, the data that we have, if I assume it as 100%, okay, only 20% of the data is structured. Okay, rest of the 80% of the data is present in the form of unstructured data. Okay, so because majority of the data is stored in the unstructured format, there is lot of research happening in this segment. How many of you are using GPT, chat GPT, DeepSeek? Is there any person who is not using these tools? Almost everyone. Even people working in the tech, non-tech, whatever might be the domain, Copilot, Gemini. Okay, so there are multiple tools. And what are these tools doing, friends? Can someone tell me what are these tools doing? Every one of us started using. Yes. What are they doing? Yep. It is making our work easy. It's not delaying our time. Whatever we are giving the prompt, it is returning us the output. Why am I explaining all this is to talk about data. If you are clear on the aspect of data, then you will understand these tools. And why are we focusing on the data is SQL completely, it is related to data, right? To escape from pressure is a kind of weird answer. Anyways, yep, good one. See, friends, these AI tools, technically these are called LLMs, large language models. What are they doing is they take our prompt, the input prompt, and they are also giving you the output in the form of text, in the form of image. Even in soon we are going to have in the form of videos, so on, multiple. So all of these, if you observe what kind of data they belong to this 80% of the category. It is unstructured data. They belong to unstructured data. And just because of this, there is lot of research happening in the field of unstructured data. Soon we will get many more AI tools. Okay, so you are supposed to upskill and focus more if you are aiming to be in the part of AI. Yes, because AI will be the future anyways. Okay, so you be into the data related zone. If you be into this data related fields, obviously you'll get all the enhancements that will be part of the data. Okay, so anyhow you can also expect the output in the form of table. Yes, right. So why am I discussing all of these things is I want to be uh, I want you guys to be very clear on the data, because SQL, structured query language, we are going to work only on structured data. Structured query language will help us to communicate with structured data. Okay, so not this, not this. We have different languages, and that language is nothing but NoSQL, not only SQL. All right. Then next to here are some of the tools: MongoDB, Cassandra, DynamoDB, Hive. Okay, there are n number of NoSQL databases also, which are widely used in the market, in the industry. Okay, we'll talk about a few in the coming 5 more minutes. Right. Then we are also using cloud. Because of this big data, we started using cloud. We are able to store our data in the form of cloud. The cloud databases came into the picture, right? So where we can store both relational and non-relational databases. Okay, either you can go and store relational data or non-relational data. So this is a clear understanding of databases. Just now we have understanding of databases, but what exactly is this database? Actually started discussing the history of database. What is this database? Database is a collection of data. So you see, this is a database in which we'll have data that can be easily accessed. We can access the data, we can manage it, we can update it. Okay, whatever you want to do on the data, you can do all the activities. You can do all such kind of activities on the databases. In simple, database is an organized collection of data. Okay, and if you see the key features, the data will be stored in the form of tables, right? So only tables? No, there are different. Depending on the data that we are going to choose, we'll choose the format. Okay, then we can also quickly retrieve, manipulate the data. Okay, you can get the consistency of the data. Okay, accessibility can be done by everyone. And tell me one thing, can everyone have the access to each and every data, each and every record present in the organization? No. It also allows us to give accessibilities. See, for example, if I work in an organization, and can I have the access to probably the salaries of the each and every employee? No. Who am I? Am I belonging to finance department? No. So depending upon your department, depending upon your job role, your access can be restricted. Yes. So all the features, and here are widely used relational databases. And these sessions, we are going to focus on very widely used RDBMS system called MySQL. Okay, so I'll talk about MySQL in the coming time. Okay, then we also have Postgres SQL Server. This is a product of Microsoft. Okay, we also have Oracle, then MariaDB. Okay, in this way we have multiple databases, friends. Like how we have relational databases, we also have non-relational databases. What is relational database, what is non-relational database, we'll understand. Okay, so under relational databases we have some databases, right? In the same way, in order to under non-relational databases we also have many databases. Out of them, widely used database is mongodb. Okay, so if you observe, what language should be used to communicate with these relational database is SQL. Structured query language will help us to communicate with relational database. Okay, it's a language, friends. But what kind of language will be used to communicate with non-relational database management system? No SQL. So majority of the folks, they get confused. There is no kind of clear understanding between SQL, RDBMS, non-relational database management system, no SQL. So this is, you know, the clear picture. No SQL, SQL are two languages, okay, which are used to communicate with RDBMS and non-RDBMS systems respectively. So what does relational database management system support? It supports to have the data stored in the form of tables. But here, depending upon the data, we can have key value pairs. Okay, we can also store it in different formats. So here we'll store structured data, here we'll store unstructured data and semi-structured data. Anyhow, I'll talk about the differences at the last, but I just want to throw some light on these terminologies. I hope it's clear, right? So these sessions, the coming 10 days, we will focus on this part. Got it? So if you see, we have the database's importance. It's a centralized data storage. Yes, for each and every organization in the industry, no one is using files to store their data. No one, seriously, 0% of the organizations. Sorry, 0%. Then what exactly these organizations, the companies are using to store the database is database, DBs. If not, if they have good kind of, if they are having good kind of, they are financially strong, then they can also go with cloud. So depending on the organization trends, but you know, even in cloud also you'll have databases only. The scenario is same, right? So let us not waste our time. I'll make it a bit. I'll take it to the next level. So let us understand what is DBMS. Previously we are talking about RDBMS. If you remove R, it is DBMS, Database Management System. What is this database management system? In short, it is a software. It is a software which allows us to create, manage, and manipulate data, which is present in these databases. Okay, so you see here this particular image, it is exactly talking in the right way. So this DBMS, database management system, this will be like this one. Sorry. So this will act as like user interface for the end users or for the applications, whomever it might be. you know so this is the database. Okay, so database management system will act as an user interface between the database and the users or the applications, whatever it might be. Okay, Then what is relational database management system? Under DBMS, we have two types. One is relational database management system, and the next one is non-relational database management system. So, relational, what exactly is this relational database management system? It's a system in which we can have relationships between the databases. You can have the connections, the relationships can be established between the databases one to the other by managing the system is nothing but relational database management system. So that means you have a table here in one of the database, and there is one more table in the same database. Can you have a relation established between these two? Yes, I can have the relationships. But if you take an non-relational database management system, you cannot have the relationships established. So that makes the primary difference between RDBMS and non-RDBMS. So this is the only point. See, whatever might be the concept, if you are able to grab it, okay, understand the core part, friends. So that when you explain in the part of interviews, okay, it should feel like you're not mug upping, you're not by hearting. If you are able to take a scenario and explain, that is well appreciated. It is well appreciated. So whatever might be the concept, try to understand the core, and try to map it with any kind of real time use case and explain. It creates a different impact on you. Okay, so this is the understanding of database management system. So the advantages, if you see, it reduces the data redundancy. This point I have also spoke in Power BI sessions. What is data redundancy? Okay, how the data is kept secured. All these points I have spoke well in Power BI sessions. So friends, if you have, redundancy is nothing but duplication. Unnecessarily, if you want to store the duplicate data, it doesn't work, right? It results us in some kind of anomalies, and these anomalies, when we have these errors, obviously we have a data crash. So that is the reason DBMS allows us to reduce this data redundancy. We'll come up with some models, right? Yeah. So we also have some disadvantages, because the cost will, the initial cost for the setup, the hardware will be initially high, but somehow your data will be in the right fashion, in the right format. Fine. Then the types of DBMS. So relational database management system, I was talking about it earlier, right? So we have that understanding. So organizing the data into relations, tables. So the widely used RDBMS systems are over here: MySQL, Oracle database, Postgres, SQL Server, MariaDB. All of these fall under RDBMS system only. Okay, each one is representing one RDBMS. So that means you can have the relations established for your data under this, RDBMS systems. Then, and coming to hierarchical DBMS, it will be like tree-like structure. Why am I not focusing on the rest of these database management system? Is we no one, or I should not say no one. Probably the usage of these DBMS systems will be very less in the market. There is a lot of demand for only two. One is RDBMS, and the other one is non-RDBMS. Only two. For RDBMS SQL, for non-RDBMS it is NoSQL. So that is the reason I'm not going, or not I'm not investing good amount of time on the other DBMS. Okay, but still somehow we have a great understanding about other DBMS as well, right? So under hierarchical DBMS, the data will be stored in the form of tree-like structure, as discussed earlier. Then network, it will be like graph. So you'll have key value pairs and all. It represents a network. Then finally, object oriented, the data will be stored in the format of objects. Now finally coming to non-RDBMS. See, the data which is unstructured or semi-structured, if you want to work on such kind of data, okay, if you want to store such kind of data in the raw format, then go with non-RDBMS system. But you know you are supposed to learn NoSQL. Like how we are going to learn SQL in the coming 10 days. In the same fashion, we are supposed to learn not only SQL, because these RDBMS systems, they will understand the commands of SQL in the same way. Like whatever the non-RDBMS systems we have, they understand only not only SQL. So that makes the difference, right? So in these sessions, we are going to learn only on, or we'll be focusing only, you know, RDBMS systems, friends. I hope it's clear. I'll make, you know, this is the complete understanding of relational database management systems. So you see, even if the picture in this image, how the relations can be established between the table and the table. So n number of relations you can establish single one depending upon the requirement. And if you are capable of establishing a relationships, yes. And how are these relationships established? We understand in the sessions. Okay, so what kind of data you're going to store? Structured data only with predefined schemas. So structured data is the data with where we store the data in the form of table with predefined schema. Yes. Then we also have some kind of constraints which helps us to establish the relationships. And what is the language that supports this RDBMS systems is SQL. So whatever we have understood so far, all of the important points, were mentioned over here, the examples, the same. Then, so I'll also talk about the relationships. Probably relationships, I'll do it at the last, because I would like to introduce SQL first before talking about relationships. So these are the data models that we have and the types. Okay, so the hierarchical data model, you know, network data model, then relational, object oriented. Depending on the database, we have the models. Okay, I'll talk about this, but I want to introduce you guys to SQL at least. Right. So the main core of the part of this course is SQL, structured query language. What is SQL? It is a language. It is a language. Akhil, is it a programming language? No, friends. It is not a programming language. It is a query language. So when I refer something as programming language, probably might be all of us are not aware of the programming. Okay, but somehow I would like to give some examples. If you take Python, if you take Java or C++, all of these will be the examples. They are the examples of programming languages, where majority of us are not interested in learning any of the programming, even including me. But somehow I have learned. That's a different story altogether. But is SQL same as programming language that we have? No, it is a query language. Okay, what is the use of SQL, or why should someone learn SQL? Is, you know, SQL is a language. It is a query language which helps us to communicate with any of the RDBMS system. Okay, and if you are comfortable in English, if you are comfortable in English, you know, you need not struggle learning SQL. Okay, got it. So Why am I talking about all of these stuff is SQL queries. The queries that we are going to learn as part of this language are related to English language. And SQL, it is earlier called as SQL. How many of you are aware of SQL named as, SQL was named from SQL? Come on, friends. Are you aware of SQL, which was actually derived from SQL? Majority of us may not be aware, but people coming from kind of tech or from IT related background, they might have learned this SQL as part of DBMS subject, right? Okay, no, yes. See, it is earlier named as SQL. You know what exactly the full form of SQL? The SQL represents structured English, QUE represents query, L represents language. I repeat, structured English query language. Isn't it? Yes. This was, it was called as SQL in the earlier days. Then, now it became SQL. It is structured query language. Okay. So Akhil, if I am able to, understand English, and if I am good, not a professional, but somehow I am an intermediate guy where I can understand English, will it be easy for me to learn SQL? You are the right person to learn SQL. Why? Because you'll observe it from tomorrow, friends. From tomorrow, when the session starts, whatever the queries that we are going to write, you know all of them will be in English language. Trust me, it is very simple. It is not a programming language. It is just a query language which is built using English. Very simple. Okay, right. Then this SQL allows us to query. You can do multiple actions. You can do insertion, update, delete. You can manage the data, whatever you want to do on the data, you are able to do using SQL. Okay, so only on RDBMS systems. So who is the inventor? This guy, the card. So it was invented in 1970. The functions are over here. We can manipulate the data. We can query the data. We can manage the databases. Okay, and we can also have the control on the transactions. Everything can be done. So why SQL? So these are the reasons. Universal, it's powerful, and it is standardized and flexible as well. Wherever you go on the globe, SQL is the only language that is used to use for RDBMS systems. In order to how I am able to communicate with you is via English, right? In the same way, if you have the data in the form of which is stored in the form of databases, okay, in tables, in order to communicate with the databases, you have to learn SQL. No other alternative, right? Yes. Few more slides. I'll not take much time because I don't want to trouble you on the day one itself. The features, if you see, we are able to achieve everything using SQL, friends. You know, uh, for better performance, you can also go with indexing. So this topic we'll discuss. We'll have subqueries. Okay, then we have multiple functions. We have data types. Okay, so whatever the sorting can be done for the analysis. You can aggregate the data. You can group the data. You can join the tables. Okay, you can get enough kind of insights. Okay, so all of these together will be the key features of SQL. What not? Everything can be done on the structured data using SQL. Okay, so the final slide where I just want to uh, focus more is SQL and NoSQL. relational database management systems and non-relational database management systems is, you see, why someone should learn SQL is, if you have the data stored in any of the RDBMS system, if the data is stored in structured format, which is tables and rows, rows and columns, so you are supposed to communicate with this data only via SQL. But under NoSQL, if you see, the data will not have any kind of schema. The schema will be flexible, dynamic. Okay, and what kind of data it supports is any key value pair, see graph, documents, any unstructured data is accepted. So in order to communicate with that unstructured data or semi-structured data, someone should learn NoSQL. Schema is fixed because upfront you are going to fix the schema. Okay, whereas under NoSQL it will be dynamic. It will change based on the data structure. Okay, so when it comes to the dynamic query language for RDBMS, it is SQL. Okay, whereas for you know non-relational database management system, it changes. Okay, so for MongoDB, we generally go with JSON like queries. So we'll come up with some sessions on NoSQL as well, because in order to put more light on these topics, we'll do such kind of sessions in the coming in the future as well. But these are the primary differences between SQL and NoSQL. Both of them are two languages. Don't get confused. Be very clear. Both of them are two languages used for different purposes. For relational database management system and non-relational database management system, okay, depending upon the data that you have, upon your requirement, you are supposed to choose the language. Then when it comes to the scalability, under SQL, we'll go with the vertical scaling, where we can add more resources to a single server. But for non-relation database management system, we'll go with horizontal scaling, because the data will be distributed across the servers. So what exactly this point we'll discuss, friends, coming session. It also supports ACID properties, the base properties it supports, and finally here we have some of the examples. MongoDB, Neo4j Graph, Cassandra, Redis, and Couchbase. So out of these, widely used is MongoDB. Then, for example, under the examples of SQL, we have MySQL, Postgres, the same one, the same examples. Time again, I'm repeating. The reason is we are going to focus on MySQL from tomorrow. Okay, if you are able to do it on your own, the installation part, okay, go with it. If not, I'll come up with a recorded video where you are supposed to just follow my instructions and complete the MySQL installation. Okay, right. So I think probably this might be the last slide. Let me check, because I am aware that yep. So right, so it's time for our technical questions, friends. Especially whoever is going for the MySQL installation, don't do it blindly, because when it comes to MySQL installation, it is not that much easy, because as part of MySQL installation, we are supposed to go with a package. It's not we don't only want MySQL workbench. We want all the components of MySQL. Okay, it might be server, it might be the workbench, or the connectors, whatever it might be. We want all of them as a package. So better take any reference to install. If not, anyhow, I'll come up with a video. Okay, I'll direct you step by step what you're supposed to do for the installation and all. Okay, so just go through it. And friends, before you leave, for every, I see majority of you leaving, don't leave the session, because what's happening is we will provide a feedback link at the end of every session. So you have to fill the feedback link. So this will ensure that you actually have attended that particular session. Then only after filling this feedback link, you are supposed to leave. because this will also make sure that you have attended that session. And based on the feedback, the suggestions that you're going to give for us, we will try to improve ourselves. Okay, so the feedback link has been anyways posted in the chat. I want everyone to fill the feedback link. And before you go to the feedback link, I just want to ask one more question. Is the pace good enough or should I reduce it? Come on, friends. Should I reduce the pace or should I increase the pace? Anyhow, I got good, feedback. It's great, right? Yep. So I'll continue as is, but from tomorrow it will be like hands-on. So try to join on time. Okay. Yep. So friends, before you leave, fill the feedback. Feedback link has been posted. Just fill it and also give a hit on the like button. Okay, and share across multiple groups, your connections, whatever it might be. Thank you so much for your feedback. And just because of your valuable feedback, we are able to do good sessions. Prolong, I'm not exactly aware of this language, but I'll cross check and I'll come back to you, my friend. Okay, I'm not aware of this prolong language. Let me do some kind of research and then I'll get back to you. Right. So as I have informed earlier, the feedback that we got from the previous programs, it might be Power BI or that Python to AI sessions program. Just because of that, we were planning to do n number of sessions in future as well. So what we are expecting from you is your interaction across the sessions and proper attendance. So when the number of people joining will be more, even I'll put more interest and I'm ready to share more knowledge with you. As I'm working in the real time, I would like to share my experience across these sessions. So ask your friends, your relatives, your whomever it might be, ask them to learn these emerging technologies. Okay, so these skills are mandatory in the real time in the industry level. So ask them to learn all these skills so that they'll be hired very soon. Right. So that's all for the day. Thank you so much for joining and making the first day of this program amazing. We'll connect soon in the next session and then we'll start learning SQL. Thank you once again, friends. Have a great day. Signing off. Bye.